Good afternoon. Welcome to this session in GIS, which is on uncertainty in GIS and error propagation. In this session, we will see about uncertainty, its concept, sources of uncertainty, and its propagation. So, let's start with the introduction. In GIS, basically, we'll deal with the digital representation of real world or computer representation of real world, where we represent real world's objects, real world uh, phenomena in the form of some GIS data model, which can be raster or vector. So, this representation of real world to digital world carries some amount of error, which may not be by mistake. There are chances that error is by mistake, but sometimes error is not by mistake, it is by the limitation of the algorithm, limitation of the measuring instrument, limitation of the device which is used to create the data. So, the error which is there because of certain limitations is known as uncertainty. So, this uncertainty or error is generally a concept when some mistake is created in the data. Uncertainty is the concept when there there is some error which is there because of certain limitations. So these limitations can be because of these three stages. These are the data creation or analysis stages. So one is due to conception, measurement and representation, and analysis. So, conception stage of uncertainty. This is about how are we going to make the data. For example, uh, anything we see on the ground or anything we see in the nature, that is in the form of polygon, means any object we see or any phenomena we see on the ground, uh, that can be either a continuous phenomena or it can be some object which is a more discrete in nature. So any object on the ground is of polygon geometry, but in GIS we have three geometries: point, line, as well as polygon. So if you look at point geometry, point does not have any uh, size. So corresponding to the point on the ground, there will be certain object, but that object will have some size. So we have decided that a certain object having size less than certain threshold limit shall be represented as point, and object having size more than the threshold limit shall be represented as polygon. So here this is about conception. We take decision that how object should be represented. For example, road should be represented as a polygon or it should be represented as a line. River should be represented as polygon or it should be represented as a line. Where on the ground both river, roads, they are having area, means they are polygon form, but in representation we take decision about its representation. So when we represent a polygon kind object in the form of line, obviously there is uncertainty, there is error in our conception stage itself. Building has to be represented in GIS. So building has footprint, it has some area, it is a polygon form, but we many times we represent building as a point. Many times we represent intercity as a point. It depends on the scale of representation. For example, when we are representing something on India level map, cities, even cities, capital cities like New Delhi, they are represented as either point or very small area. So this representation is more related to scale of representation. So based on the scale, the decision is taken based that it should be represented as point or polygon. And whenever a polygon is represented as point, there will be error in the attribute of that particular object as well as for the surroundings. Then measurement and representation. So when we have to measure something, either we go to the ground and do the measurement, like if we have to collect the coordinate of certain location, we can use handheld device, your mobile device or GPS device, go to the ground, collect the coordinates. Or we can use some secondary data like satellite imagery to get details of the certain features from the imagery. So when we are using satellite data to create the features, like we use satellite data to identify roads, we use satellite data to identify buildings, rivers, different kind of objects, uh, different kind of land use, land cover types, they are used, they are discriminated from the satellite imagery. Now in this case, when we have to identify something from the image, the resolution of the image has to play a role. Based on the resolution of the image, we will be able to discriminate, or we will be able to identify different kind of objects or different level of details. If resolution is good, like centimeter resolution, a lot of details can be seen in the image, like in centimeter resolution we will be able to see the vehicles on the road also. But when resolution increases, like from centimeter to meters, let's say it has become 20 meters, now our resolving power will be limited, we will not be able to see vehicles on the road, we will not be able to see narrower roads, only wider roads can be seen. We go for 50-meter resolution, building boundaries cannot be seen. So building boundaries will not be seen, which means we will be not able to mark the boundaries. Even if we are having resolution 20 meters, we will be able to see the boundary, building boundaries or footprints of the building. But the whenever we mark the boundary, there will be error in the position of the boundary itself because of the larger pixel size. The boundary of any object is very thin, but when 20-meter pixel size is used to represent a boundary, it will be representing area. So finer resolution can give better data, coarser resolution can give more uncertainty in smaller objects, especially when it comes to the boundary. There will be more uncertainty when boundary is created with coarse resolution data. Density of the observation is also matter of great concern in case of uncertainty. For example, we are using handheld device GPS to collect coordinate of any point. So coordinate of the point will not be more accurate when density of observations are lesser, because whenever any measurement is performed using any kind of instrument, the measured value given by instrument is basically combination of true value of that location, then instrumental error or systematic bias, and random error uh, of that measurement. So true value anyway we will not be knowing, most of the time we may not be knowing the true value. The instrumental limitation can be find out, means systematic error can be found out by doing proper validation of the instrument values, and random error will be there in each observation, which can be because of atmosphere, which can be because of the uh, time you are considering position of satellite, which can be because of person handling. There are a lot of factors which uh, because of which random errors will be there. So when less number of observations are taken, there will be more role of random errors. But when more number of observations are taken, some average of the random errors will lead to smaller number or zero. If we take a lot of observations, then sum of or mean of random errors will become 0. So we take a lot of observation and find out mean of all the observations. In the mean process, in this mean calculation process, the mean of random errors will become 0 and we'll get mean of true value. And systematic bias we can calculate. So average value of large number of observation gives us more precise and more accurate value. So fuzzy natural boundaries are another source of uncertainty in case of measurement. So suppose we are digitizing land use land cover, where a lot of land cover features are there, and we have to mark the boundary of those features. So whenever we are making the boundary, we are making straight lines, but nature is not too regular to be fitted in the straight line or to be fitted in any regular shape. Boundaries are very much zigzag in nature for the uh, boundaries are very zigzag for any natural phenomena. So just look at the boundary of any uh, natural forest, it will be a lot of zigzag, but we have to mark boundary in using our line geometry, polygon geometry. So here identification process itself introduces the error. Then georeferencing process. Georeferencing is very much important when we have to map the features to geo coordinates. In GIS, if we are not mapping the features, if we are not performing proper georeferencing, then there is no use of GIS. We will be without georeferencing, whatever digitization, whatever data point line polygon will create, that will be just pictorial art kind of thing. They will be of no use for any analysis, or they may be of least use for any kind of analysis. So georeferencing is very important uh, factor in measurement and representation concept. But georeferencing has to be very accurate. For that, accurate coordinates are needed. So the process of georeferencing itself brings the uncertainty. So in georeferencing, what is happening, we have some image which is non georeferenced, and we are mapping coordinates of these image to earth coordinate or geo coordinate. For that, we are collecting some samples from the ground, and we are fitting a function between the ground collected points or ground collected position and positions present in non georeferenced map. So this fitting a function, whenever it comes to fitting a function, it is statistical fitting, where some parameters will be calculated from whatever coordinates we are giving to perform the georeferencing. But there may not be a systematic relationship existing between geo coordinates and whatever image we are having. So if no systematic relation is existing, so whatever function we will be fitting, there will be certain amount of error. So that is why when you, if you have performed georeferencing any time, you will get RMSC value which is non-zero most of the time. So what we can do in this case to avoid more uncertainty, we can uh, ensure taking the coordinates which are more accurate. When coordinates will be more accurate, when density of observation of the points will be larger. So that precaution we can have, but obviously zero error will not be there. There will be certain amount of error. Then digitization error. So whenever we digitize, we mark the boundary. So as discussed, the whenever boundaries are marked, because of fuzzy natural boundaries, position of boundaries will not be correct, and based on the scale we decide something need to be represented in the form of polygon or in the form of point. So if you are representing some object as a point, obviously there will be certain error, and there can be certain error like digitization errors which are snapping, which can be resolved by snapping. Some errors are overshoot, undershoot, sliver errors. So these errors are left out many times, which need to be taken care when digitization process is going on. Instrumental limitation is about our limitation to measure. So limitation of GPS to measure the accurate coordinates when measurement is performed for temperature. So there will be limitation of any temperature sensor which being used. So because of these limitations, these concepts, density of observation, natural boundaries, issues, so we get certain error in the data created, which is also known as uncertainty, because the error introduced is unknowingly error is being introduced, not the by mistake. Then analysis part. In analysis part, whenever we do any kind of modeling using GIS data, so model is basically a set of numerical equation, or in model a lot of calculation goes on between input and output data whatever we are having. So in this process a lot of functions need to be approximated, because relationships many times, natural relationships are not a simple linear regression. They are too irregular to be fitted to linear regression. Most of the time you will find irregular relationship, but sometimes, or most of the time again, relationship is irregular but function is not known. So we have to assume some function to fit a function between input and output data. A relationship need to be assumed, which can be a linear or non-linear, some logarithmic relationship or trigonometric relationship. So relationship has to be assumed. So this assumption process introduces some amount of uncertainty in the data. For example, there is uh, some data between temperature. Temperature distribution means data is observed at different locations. So it will be a data of temperature versus latitude, longitude. So we are fitting a relationship to find out the temperature at any latitude, longitude location. So I mean I have uh, conducted 10 observations of temperature at 10 different locations. So in these observations we have temperature value and longitude, latitude value of those locations. Now I want to find out temperature of any 11th point where coordinate, where a function is needed, and we just want a function where we can input latitude, longitude. So we can assume a linear function here, a non-linear function, a polynomial function, any kind of function, but all these will be assumptions, because temperature variation is true with respect to location, especially when you go for hilly region. But what is the relationship? That's very irregular. So any function being approximated, that will bring some certain amount of uncertainty. Then numerical error in computers. When we perform some calculations, when we perform some calculations in the computer, we need to assume the, we need to limit the precision, means that places after decimal we have to limit. So the, in this process certain amount of error, for example coordinate of any location is 30 degree or 30.12569782 these many places are there after decimal in this coordinate. So if computer is assuming up to 2 decimal digits, so after 2 decimal digits a lot of uh, precision is being truncated. So this truncation error will lead to some positional error in this case. So, so not only position, any calculation, if precision is controlled and it has to be done, means we have to limit the places after decimal, otherwise calculation time will be higher. So this also brings certain amount of uncertainty. Then error propagation is also very important steps to understand. Sometimes we create the data and assume that since we have created the data and there is a very less amount of error present in the data, we know that there is error but we don't want to rectify it, and we know, we say that very less amount of error is present, so it is not going to harm. But when data goes for multiple processing steps, then in each processing steps that error gets increased, so final output will have more error. For example, weather prediction, let's say rainfall prediction is need to be done. Rainfall prediction is very complex process, a lot of factors need to be there, a lot of uh, observations like temperature, pressure, humidity, their speed, velocity basically, uh, and how things are changing at different locations. So holistically, a lot of factors need to be considered in this rainfall prediction. Each factor uh, will have certain uh, observation process. For example, temperature is one factor, pressure is one factor, humidity is one factor. So all these need to be observed using different instruments. These instruments will have some error. So when error is not controlled at measurement stage itself, means at stage 1, if error is not controlled, in the modeling process error will get increased, and final output that will get for any objective like rainfall prediction or any other, so the final output will have more error, which will make our data untrustworthy. There are certain uh, stages of error, like we assume digitization is error free. So based on these errors, because of certain assumptions, so digitization is error free. We cannot have error free digitization. There will be errors in the boundaries, especially data source is error free. The input data, whenever we are creating the data, we are creating the data using certain reference data. Then we assume that reference data is error free, means satellite image if you are considering, and uh, in the digitization process we insert some error. But what if the satellite data itself was having error, positional errors? So our digitized output will have more errors. Boundaries are sharply defined, means whenever we are making the polygon, so whenever a polygon geometry or line is made, it is basically marking the sharp boundary, and nature is fuzzy, so sharp boundaries does not exist, but we assume that boundaries are there, so we make the boundary. We also assume that algorithms are deterministic. So but it may not be the case. Some algorithms may need multiple observations. There are uh, probability based situations algorithms, stochastic algorithms, but we assume algorithms are fully deterministic, which means parameters are very well known. So in these cases, because of these assumptions, our data will have errors, because these assumptions itself are not right or completely wrong. So in the GIS data, we can have uncertainty in the position, or we can have uncertainty in the attribute. So what is attribute? Attribute is basically, if you have seen GIS data, the information in attribute table of the layer. So which is a property of any object, which can be name, which can be locality, which can be related to ownership. So attribute is defined as the characteristic or nature of the object or inherent property of the spatial data. For example, when we are digitizing land parcel, so location, latitude, longitude will be there anyway, but locality, the land parcel belongs to which village, the who is the village head, how which crop is grown mostly in that region, who is owner of that region, what is the total area, what about the surroundings of the area, there is canal present or not. So a lot of attributes can be there corresponding to any object or any feature we draw. So the attribute measurement itself can have a lot of errors. So this error can be basically because of these things, which are resolution, mixed pixel concept, the atmosphere, and aggregation disaggregation process. So in spatial resolution, as discussed, Spatial resolution helps us to identify objects more accurately. So when spatial resolution is poor, the object we will not be able to identify more accurately. When we are not able to identify the object accurately, which means we will be making the line or polygon at certain location which is not accurate. When we make the polygon at wrong location, automatically attribute error will be there. For example, we have to digitize some land parcel which is present beside the road, and we are having, so in this case basically we have to digitize road as well as land parcel both. Now to digitize both of them, uh, suitable satellite imagery is required where uh, proper properly road and land parcels can be discriminated. But what if we have the imagery where resolution is poor? So when poor resolution is there, properly we will not be able to discriminate the feature. So when we will not be able to discriminate the feature, we will make them at wrong locations. So when features are marked at wrong locations, which means we have this road for example, and beside this road there was one land parcel which need to be digitized, but when resolution is poor, what will happen? This, we will not be able to discriminate boundary of land parcel, so we can by mistake we make land parcel boundary something like this. Because of resolution this can happen, and we digitize road as this is the road, this can happen. So what issue you can see here, this region which was actually road portion, because of the limitation of the resolution of the data, we were not able to identify this place properly that this is road or land parcel. So it is marked as land parcel. So this region has attribute error, which will be called as uncertainty, because at that level or that spatial resolution nobody can discriminate these two features. That is why there is uncertainty in the attribute. But when we are digitizing at larger resolution, we may able to overcome with this uncertainty. Mixed pixel another is another uh, major drawback or major limitation on our ability to discriminate the features. For example, we have these two polygons, one is forest and another polygon is cropland. Now the image which we have got, that image has pixel of this kind, means the pixel is falling in partially cropland and partially in forest, this way. Now this is the mixed pixel. Why? Because the signature, the whatever reflected energy is stored by the satellite, that energy is the combination of reflected energy from forest part and from cropland part both. Now the energy stored at the satellite, that will neither have true property of forest or true property of cropland. So in this case, what should be done? This pixel should be assigned forest or this pixel should be assigned cropland. It will be very difficult to discriminate. So in this case, either we will be marking the boundary, from here this way, or we will be marking the boundary here this way. So in both cases there will be error for the part of the pixel falling in different region. So if you are marking this boundary, so what is happening, this entire pixel is assigned class forest. Now this portion, when this entire pixel is assigned class forest, this portion is having wrong attribute. So this wrong attribute is not because of error, this is because of uncertainty of pixel size as well as uncertainty because of mixed pixel. We are not able to identify in which region or in which class it belongs. The atmosphere also plays a great role for attribute uncertainty, because whatever signal satellite receives, that gets contaminated by the atmosphere. So atmosphere has a lot of gases, aerosols, which because of the particles present in the atmosphere, light gets scattered, absorbed. So whatever light gets received by the satellite, that is whatever energy gets received by the satellite, that is contaminated. And contaminated signal hampers our ability to identify the feature. So when we will not be able to identify the feature, we will be making the mistake in the attributes. Aggregation and disaggregation process, many times we need to aggregate the data to larger unit, or sometimes we may need to disaggregate the data. So in this process a lot of detail gets lost. For example, we have data at village level, and at some time we aggregate the data to make it to block level. So village level details present in the data, that will get lost. So whatever attribute information was present at village level, that will get lost. So that is purely because of the scale at which aggregation was done. So if there are so much uncertainty present, or there are so much chances of uncertainty in the data, what should be done to have trust on the data? Because certain level of uncertainty may be acceptable for some application, or different application may not be okay with that uncertainty. For example, I have made the roads, I have digitized the roads just to make the map, just to show overall that where national highways are present in the India. So in this process, even if there is 1 or 2 kilometer deviation of the main national highways from their actual location, on India scale no one can identify, no one can discriminate. So if I make a map of national highways of India where there is 1 kilometer deviation in the national actual location of national highway and lines when I have marked, so with this deviation if I am making map for the India, there is no issue at all, because it is not going to affect our ability to visualize the roads, because on the map they will not appear deviated, because 1 kilometer distance at India level, that's very less. Width of India is around 3000 kilometers, so 1 kilometer is just a small ignorable error. But if I give the same data to you for using that data to perform network analysis, or if I give that data to you to use that for navigation purpose, their same data will not be helpful. Navigation purpose means someone will be using the data to move, to take turns on the road, take turns on the road, uh, to change the roads for junctions and all. Uh, so what will happen in navigation process when suppose you are using Google map where there is 1 kilometer error in the location of the roads, so it will show that there is road present, take a turn, but you will see that there is nothing present on the ground. So for navigation purpose, very accurate data is needed compared to making a map at smaller scale. if if I have to make a map at larger scale, same data will not be helpful, because 1 kilometer error in data for India level will be okay for that map. But if I am using that 1 kilometer error road data to make map for Dehradun city, that will be disaster, because 1 kilometer distance on Dehradun city scale, that is too much. So visually anyone can identify that there is error. So basically assessment need to be done for the data to build a trust or to take decision that it should be useful for your case or not. So accuracy assessment, which is also part of data quality. So and data quality is subjective. Data quality depends on the purpose of the data, the usage of the data. So here assessment, whenever any accuracy assessment need to be done, there is need of the reference data or actual data for which we have strong reasons to believe that the reference data is of good quality. For example, I have made a road which is having 1 kilometer error, means there are high chances that road, the distance between the line I have created and actual road, there can be 1 kilometer deviation. If I am using another reference data which itself is having 500-meter deviation, and I want to do the accuracy assessment, so we will not be doing the so that will not be correct accuracy assessment at all, because the reference data itself is having error. For example, we get a reference data which is having 2 kilometer error, and my data itself is having 1 kilometer error, so accuracy assessment will not be correct. So accuracy assessment always need to be done with a reference data or good quality reference data for which we have strong reasons to believe that data is of good quality. The reasons can be anything. It can be trust on the organization, trust on the process of data creation. Means if I have created the data and I am telling you entire process that how I have created the data, then you will get the trust that yes, this data, the person he is claiming that this way, and this input data is used to create road data. So there will be higher chances that he is telling truth and data is of good quality. Or there can be some organizations entrusted with the responsibility to make the data. For example, I have to digitize boundary of India for some purpose. So political boundaries are very serious issues. We should not have wrong boundaries, because it will be if we have wrong boundaries, so either we'll be showing our area to other country or other country's area in our country. So in this case, the boundary which I am digitizing, I need to do proper accuracy assessment. So how will I get good quality data? So there is organization in our country, that is Survey of India. So the Survey of India provides a good quality political boundary of our country. So that organization is interested with the responsibility of these things. So whatever boundaries they are giving, you can have more trust that yes, they are giving the boundary obviously after a lot of quality assessment. So you can use that boundary to do the assessment for your data. Or you can go to the ground and collect high resolution information. Uncertainty in the position, as we have discussed earlier, uncertainty in the position is because of uncertainty of the nature or randomness of the nature. We are not able to identify the correct location of the boundary or any object, and we making object at wrong location. So obviously there will be error in the location. Then lack of observation, this also we have seen in detail. When there are lack of observations, there will be high chances of random errors. So because of random errors, our position will get shifted. So whenever position gets shifted, there will be attribute error. Means positional uncertainty triggers attribute uncertainty, while vice versa is not true. So which means if I am having positional error in the polygon made for forest class, so positional error in forest class will lead to positional error or attribute error in that particular class. So my actual boundary was here, this is forest, this is cropland. So when I am making the wrong boundary like this for the forest, so this region is wrongly defined as forest, whereas this was supposed to be cropland. So when there is positional uncertainty, there will be attribute uncertainty always, while there can be attribute error for the correct uh, geometry or correct position of any object. Then measurement limitations, when we have some instrument like GPS also has certain limitations. So because of limitations of measuring instrument, there can be the positional issues. Now modeling in the uncertainty in the modeling process. As long as you are working in the discipline of GIS and remote sensing, you will be using some data and you will have some reality and fitting the relationship between data and reality. So the simplest relationship is a regression model, where we fit a model between input and output. For example, I have to find out a crop yield from the satellite based observations. So yield, we need a data of yield which will be calculated by marking the sample plots, and for those plots yield need to be estimated from the ground, and there will be certain remote sensing observables like NDVI, LAI, and many other parameters can be there, which can be observed from remote sensing based methods. So if you are able to fit the relationship between crop yield and remote sensing observables, we will be able to tell about crop yield for any location where observation is not done, where is ground observation is not done, because that's time consuming and very rigorous assessment need to be done. So but from remote sensing observations, we can, from remote sensing platforms, we can have observation of other related remote sensing observables like NDVI, LAI, and soil moisture, uh, ET, and a lot of things. So if we are able to fit the relationship at any pixel location, remote sensing observation will be available. So we put remote sensing observables in the equation and we will get the crop yield. So here regression model can be considered, that can be a linear regression model, non-linear regression model. So obviously linear regression model will not be good, because as I told, relationship between nature and observations, that is not a linear one, that's very uh, random or very non-linear relationship is there. So the assumption we are making that there is a regression model, particular regression model present between input and output, so that itself brings the uncertainty. For example, in some case there exists a 10th order polynomial as true relationship, but we are fitting first order polynomial, so there will be uncertainty. Least square adjustments. Least square adjustments are needed even for georeferencing process. There is a need of the ground coordinates, image coordinates, and a model which will be used to fit the relationship. Calculations of area and volume. So many times we need to calculate the area. For example, I have the polygons representing ward of any city, and I want to find out population density ward wise. So in that case, obviously when someone goes to the ground and starts measuring area of the ward, particular ward, using the meter scale, that will be too laborious, time consuming, and practically it may not be possible. But yes, from remote sensing of images, we can identify the boundary of the ward. At most, we can use handheld GPS and move along boundary of the ward, and we'll mark the boundary. Now, when population density need to be calculated, population is calculated, or population is known from the census or other door-to-door survey methods. So we know the population, we can get the area, and divide population by area will give me population density. But here area calculation process will have uncertainty. Area itself will have uncertainty because of the process involved. What process? For area we need coordinates. Coordinates are coming from GPS. So GPS observations itself have uncertainty. Using these uncertain coordinates, we find out the area, more uncertainty will be there in the area. If we are using satellite imagery to mark the boundary, the satellite imagery has certain issues like spatial resolution, mixed pixel. Because of this, there will be issues in the uh, actual boundary on the ground and boundary which we have created. There are high chances of deviation, at least 1 pixel deviation can be there. So in this case, uncertainty in the measurement process will lead to uncertainty in the area calculation process also, that to more uncertainty. Similarly, any modeling we are doing, that model needs the observations. Observations bring some uncertainty. So the model output will have some uncertainty. So this is just schematic representation. Here we have a model needs some input variables, and input variables will have certain amount of uncertainty. So the model output will have more uncertainty. So if this is the case, we should be able to comment on how much uncertainty will be there in the modeled output. Why we need to say? To have more trust. Like based on the input, there will be certain uncertainty. We do the modeling and say that there is this many percent of error in the output. So that output will be more useful. With more trust, I can take my decisions. So that can be the percentage of error or probability of the actual value. For example, these days when you see the rainfall, just use any uh, weather app, they will tell about that this much amount of rainfall is going to happen next 1 hour. But along with this, they also tell that what are the chances, probability, like 30%. So if the model is saying there is a rainfall going to happen in next 1 hour, but probability of occurrence of rainfall is 30%, which means there is very less probability. So we can assume that there may be a very less rainfall, or there may be no rainfall in next 1 hour. But when the model output says that there is going to be a rainfall of 10 millimeters, and a probability is 95%, then there are high chances. So then we can take decision that what to do when a lot of rainfall is going to occur with this much high probability. So if probability is higher, there are more chances of occurrence of the event. So that will make our trust on the data. If assume that rainfall model is just telling that rainfall in next hour, next 2 hours, without any probability of occurrence. So in that case, what will you do? All the time you will be in the dilemma that there is going to be the rainfall, but there may not be rainfall, so you will lose the trust on the prediction. But prediction was not wrong, prediction was correct. There are chances of rainfall, but there will be rainfall, but the chances are less. So when chances are also told, you will see that there is going to happen something or not. So that's why as a scientist we need to tell something about uncertainty of the output. We can tell about uncertainty of the output when we know uncertainty in the variables, when we know uncertainty in the observations. Also in the modeling process, what happens? In modeling process, we have model is basically a set of equations. So equations, there will be assumptions of the relations, linear, non-linear, there will be some truncation error, there will be uh, truncation error means numerical error. So the uncertainty of the input and uncertainty of the modeling process will lead to certain amount of uncertainty. So when we know about how much uncertainty is there in the input and how much uncertainty model is going to add, then we can comment on output uncertainty. So just simple model, this is just a linear regression model where x1 and x2, these two are the observations, beta 1, beta 0, beta 2, these are the parameters, and epsilon is the random error. So here y is my output. So x1, x2, these are the measurements. So there are high chances of uncertainty in these measurements. So because of these measurements, there will be uncertainty in the output. And beta 0, beta 1, beta 2, they are the parameters which need to be estimated from the observations. So there is chances of uncertainty in beta 0, beta 1, beta 2. So there is chances of uncertainty in the parameters. So as well as in the input also. So these two uncertainties need to be combined to know about uncertainty in y. So this, as I told, uncertainty about the variables, uncertainty about the parameters, and uncertainty about the model. In the modeling process, we can have these uncertainty. So all models are wrong, but some are useful. This statement is basically saying that whatever model we are making, it is not correct. It is not 100% correct, because model we in model we are assuming the relationship is in natural phenomena. So that defined relationship does not exist, or a two irregular relationship exists between the natural phenomena. And if we are making the model, we are limiting to certain structure of parameters. So that is why models are wrong. All models are wrong, but some are useful. We are able to fit the relationship up to some extent. So that's why some becomes useful. So in the regression process, we estimate beta 0, beta 1, and sigma square is the error of estimation, standard error of estimation. We can also find out the confidence interval and prediction interval for whatever is being predicted. So still, did we choose the appropriate model? So that is again depending, that is again the subjective decision that depends on the purpose of the model based on the uncertainty estimation. So anyway, whenever we are fitting a regression model, we can find out the uncertainty in the fitted parameters also. So based on the fitted parameters, uncertainty in the fitted parameters, we can decide that whatever model being chosen is appropriate or not. Many times in GIS, we may need to combine the vector data with raster data. So this combination process may need conversion of vector to raster or raster to vector. So this conversion process requires a lot of intersection, overlay operations. So that that is again a source of uncertainty. The error because of rasterization of a vector map, that gives the uncertainty, or vectorization of raster again gives the uncertainty. For example, I have a road of this kind and I want to convert it to raster. In case of raster, this kind of road will not be there. Instead of in raster, there will be pixels representing the road. There will be these kind of pixels representing the road. So what is happening here? When pixel is representing the road suddenly got the width. So anyway, these will be square pixels or rectangular pixel. It depends on how you are willing to represent. So the road which was a simple line in raster representation, it will become this kind of pattern of pixels. So when road becomes this kind of pixel, it is going to affect the area of the road. It is going to affect area of other neighboring classes also. Similarly, if we have road already present in the form of pixels of this kind, suppose we have a road which is of this kind in raster and I want to vectorize it. So one way is connect the center of pixels and make the road, or make this kind of road, or make this kind of road. So whatever way we choose, we are not going to get smooth road. So what will be the issue? What if I am making this kind of vectorization? Road on the ground will be a straight one, but from the raster to vector conversion, this kind of zigzag effect we get. So this deviation will be present in the data. This deviation will be basically uncertainty in the position, or error in the position. Uncertainty because this deviation is not human generated. This is because of the data model. That's why it is uncertainty. And now what will happen because of this uncertainty? If there is some polygon present around here, for example this is some forest class, so area of this class will get disturbed because this class was supposed to be up to road present, but road has deviated, so area of the nearby feature will be different, and this is going to affect further operations. For example, if I have to find the number of schools present in 500 meters of the road, so if position of the road has shifted, the final output will also be affected. So the mixed pixel we have discussed a lot. Error in the digitization process. This is the error in the digitization process. So this curve you can see, curve is the actual curvature present on the feature, but when we digitize anything, we digitize it by making lines. We make one point here, make another point, another point, another point. We join a lot of points. So here if we make one point here, we make one point here, it will join it with straight line and straight line here. So this way the curvature portion is missed. So this curvature portion, missed curvature portion will lead to positional uncertainty in the road. Why this error will be there? Because of the radius of curvature, you need to put a lot of vertices, means you need to put a lot of small lines. For example, instead of digitizing by making 3 points here, if we digitize it by making a lot of points here in this way, then we will be able to capture the curvature more properly. So yes, if we are making a lot of points, then we will be able to capture the curvature, But sometimes when curvature is very uh, large, then practically it may not be possible to have so many points. Also, it is not needed to capture the curvature with very good accuracy always. Sometimes you may need, sometimes you may not need. It depends on the purpose. When we overlay two maps, depending on the quality of digitized boundary, you will have uncertainty in the output. For example, we have created one map which is of different kind of land use, land covers. We have another map which is of just small boundary, and I want to extract the feature coming under this boundary. What if there is uncertainty or error in the boundary of this rectangular polygon I made? If there is uncertainty in the boundary, so wrong region will be clipped out. So, with this, I will end the lecture. And in this lecture, we have seen basically the importance of uncertainty and error, and the uh, importance depends on the scenario of application, or which means it is very much subjective, and it depends on what, in which area you want to apply certain data. So in depending on that, decision has to be taken about the accuracy of the data, which can be positional or attribute accuracy. So I will stop here. You can post your queries if you have any. We'll attend the query after a short break. Welcome back. Now we will see your queries. So there is one question: what measures are taken to reduce the uncertainty? So when it comes to taking the measures, you have to look at the causes. So whatever causes are, whatever factors uh, leading to uncertainty, you have to reduce those factors. One is the limitation of instrument performing measurement. For example, when you are performing measurement for positions, just you are collecting point of interest locations on the ground, so you can use high quality GPS to get accurate points. So that's one. Another thing, suppose you want to perform measurement of temperature or rainfall using weather stations or any sensors you want to install. So quality of the sensor you are installing, basically systematic error there should not be there, and those sensors should be leading to less random error of measurement that can be leading to reduce uncertainty. Then when it comes to identification of features from the map, there you have to look at the good quality of satellite data. Good quality means, again, it's again a subjective. You need to have good resolution, you need to have resolution in terms of spatial resolution and good radiometric resolution also. There should be a proper correction for the atmospheric effect, there should be proper correction for the geometric effects, uncertainties. Then if you are taking these precautions, there will be less uncertainty in the data created. What is the order of uncertainty in the three geometries? So it's difficult to say what is the order, means in which geometry there will be more uncertainty. At the end, you can see all uncertainties are uh, all geometries are made up of points. Point has only one point, line has many points connected, collection of points connected, and polygon has closed loop. So means start and ending points are connected in case of polygon. So always there are points. So it's difficult to say which geometry will have more. Means suppose I am collecting just one point of interest, I can have more uncertainty there if I am not taking large number of observations. If density of observation is lesser or observations are lesser, there can be more uncertainty in just one point. If you are taking proper observations with proper instrument, there will be lesser uncertainty in road or polygon being created. When we are creating data using this point line or polygon using satellite imagery, again it depends on how we, which feature is being identified. If the point is being located, is being identified for the feature which is coming in a pixel which is having mixed pixel effect, which is present on the boundary and all, point can have more uncertainty. If polygon boundary, the boundary of the polygon is basically a zigzag boundary or fuzzy boundary, in that case polygon will have more uncertainty. So it can be any geometry having more uncertainty, so there is no definite order. So there is another question: how much accurate is Google Earth? If it is more accurate, can we take reference points from it? uh, I don't know accuracy of Google Earth. Uh, it is somewhere around 5 meters. That's what I can say. If it is more accurate, then we can take reference points from it. So it depends on the application. if your application requires a centimeter level uncertainty, obviously reference points from the Google shall not be taken. The uncertainty is around 5 meters from the Google. So if requirement for your analysis is uh, more than 5 meters, then you can use reference from Google. For example, you are identifying the different classes using modis data. There you can take Google as the reference. Why? Because uncertainty of Google uh, is very less compared to uncertainty which will be there for the data created from modis. So in that case you can have. How we can practically differentiate between uncertainty and error? Difficult. Also, most of the time these terms are used interchangeably. In place of error, uncertainty is used, and in place of error, uncertainty, error is used. So at most you can use some reference data to know about error up to some extent, the accuracy assessment process. There is another question, how to retain attribute data even after aggregation. Uh, After aggregation, the smaller geometries will be lost. So, geometry wise referencing will not be there for the attribute data you will be having. So, at most, for example, you have a lot of polygons. Uh, for example, I have a word map of a city, and later on I want to aggregate this data at city level, which means whatever is inside the city that has to be merged with the city boundary. So in this case word geometries will be lost, but we can have attribute data, means in the city geometry attribute field itself, city geometry attribute record itself, we can have how many words have been merged. So that way we can have a column where the data, the geometry which has been merged, that can be recorded. So at most this only can be done. So there are no more questions. So with this, let's end the session. Thank you for the attention.